Varmt välkomna till dagens Radartalk där vi ska prata om Edge Computing som är ett område som inte alltid är helt lätt att hitta affärer inom kanske, men vi ska försöka hjälpa er att visa vilka branscher som behövs eller som lämpar sig för det och vilka affärsmöjligheter som kan finnas. Och med oss har vi Radars vd och grundare Hans Werner, Rhys Oxenham, Senior Director Engineer at SUSE, and Jens Yhrefors, Nordenchef at SUSE. And that's why we talk English. Men vi ska också säga att det passar på att ställa frågor i chatten. Det går att göra under tiden. I will start with the first and most obvious question. What is edge computing? I don't sure that everyone knows that.
Yeah, I think that's actually a very, very good question. When I ask different people what their answer is to that question, I get hundreds of different answers. The way that we like to describe edge computing is, and it's a very kind of general answer, is everything that resides outside of a data center or a public cloud platform. So we often talk about pushing compute and the collection and the processing of data much, much closer to the user, the source of data, or the subscriber in various different use cases or market segments. So if you think about historically, your compute and your infrastructure either resided in a data center or in a public cloud type setting. Now, due to many different market dynamics, use cases and requirements, we're talking about putting infrastructure, compute infrastructure, the collection of data. You know, it might be a sensor in a room, it might be a production plant in a machinery setting. We're talking about collecting that data, processing that data, and utilizing that data where it makes the most sense. We can make decisions very, very quickly.
And that's the most gain of it, that you can do it quickly, or?
Sometimes it absolutely is. The fact that you have the ability to act on that data where it actually matters. Let me give you an example. If you think about a medical setting and you are collecting data that might be, it could be an X-ray or an MRI scan. If you can use a computer and use the capabilities of a computer, such as artificial intelligence, machine learning, and where you're able to use acceleration techniques in a computer, in the computer there and then, you can make decisions, you can detect anomalies, you can act upon that data very, very quickly without relying on, for example, sending that data back to the data center or the public cloud where there is a delay in processing that, where you're reliant on the connectivity between that medical setting and the back-end infrastructure. If you're able to make use of that data very, very quickly, that is a unique business advantage and also a much bigger advantage for the patient.
And do you have some kind of good example on business cases where they actually use edge computing that's easy to understand?
Yeah, excuse me. So, when we talk about edge computing from a SUSE perspective, we're active in a number of different industries or market segments. So for us, we look at retail, manufacturing, medical or hospitality, transportation, and telecommunications. So it's quite a broad span of different use cases and market segments. And so a very easy one to understand is mobile phones, as in the telecommunications network that we all rely on that connects our mobile phones to the internet, and it's able to allow us to make phone calls and send text messages, look at social media and so on. Now, if you look at the rollout of 5G networks, what we're seeing is that there are many more base stations being created. There are many more base stations being created because so many more subscribers are using that data. It's not just mobile phones now. We have computers that are connected to the internet. You have sensors and various different devices that are connected to the internet through these towers. But also it's the amount of data that needs to be processed through those towers. You need many more of them to be able to achieve the promise of 5G connectivity. So when we think about edge computing isn't just retail stores. It's also base stations for mobile phone towers. And so it's a very easy example to try and understand. We have these base stations everywhere. They need to be connected. They're connected to the back-end infrastructure, they're connected to your mobile phones, and those systems need to be managed, life-cycled, upgraded, and monitored.
Why retail?
Why retail? Well, retail is a good example. When I think about kind of the definition of edge computing, for us at SUSE, we tend to put customers and use cases into two general I guess, segments. It's organizations that have been using edge computing for a long time, but perhaps haven't really known it. And retail is a good example for that. When you walk into a retail store, for decades, you've been able to go in there and do payment processing, right? You go in there, you pay for your groceries, things get scanned, there's a computer of sorts there, and it takes your payment. That is an example of an organization that has been doing edge computing for a very long time. On the other side, you have organizations that are looking to exploit the capabilities of edge computing for the first time. They're doing so because perhaps connectivity allows it. Compute is either cheaper, faster, or more capable, especially when you look at AI. And they're utilizing edge computing for the first time because it gives them a unique business advantage. There are plenty of examples of this if you look at power generation and distribution. These sort of things are new. But to go back to your question, why retail? Well, there are lots of examples of where we're having to modernize retail infrastructure. One example we've worked with in the past was using edge computing within a retail store to track customers as they walk through the store. And why would they do that? Well, they want to better understand how long people are staying in the store, whether the placement of the goods that they're trying to sell is in the best order. You know, is there an opportunity where they can place things more strategically to boost sales, right? And so there's lots of different examples there. And in that setting, they're able to utilize technology now because it has more capabilities to do detection of individuals, perhaps detection of theft. And so there's lots of different new things that people are doing with edge computing that has additional business advantages, even though in a retail setting there's been compute in the stores for many years.
Yeah, I heard of one example of a retail chain in the United States, and they have about 2,000 retail stores. And before they had one huge central data center. Now they are running 2,000 local data centers instead. And I think the reasoning was the attention span they have, which is individual in each store around the decision making of the customers. And the second one was to be able to run the store independently of internet if there is interruptions or distortions in any way.
Yeah, no, entirely right. Sorry, did you want to?
No, I think it's a good example, and specifically what you talk about, the call it discontinuation or the uncertainty of connection. When you run everything in the data center, you're dependent on constant connection to process data, to get the calculations back, or to get results back in some shape or form. And within edge computing, it's really vital to be able to use the compute power without relying on the connection being there all the time.
Absolutely.
So that's a very good example that you make.
It's about being self-sufficient. Yeah. If you look at these retail stores, or maybe a more simple example could be a pop-up store somewhere. You know, it might be a fast food cart or a coffee shop that pops up on the corner. They still need to be able to take payment processing there and then. They may need to do some kind of online ordering system. All of these things require connectivity, but everything is so much better connected nowadays, and there's much more capabilities, and smartphones being able to manage those orders. These are all really good examples of how edge computing is continuing to push the envelope on what is possible.
Yep. But if you talk about if you're a business that wants to think about edge computing, it sounds interesting. Where should I look to actually find the place to use it? How do I think in that case?
Yeah, I think that's an interesting one. As I said, there's these kind of two broad categories of organization. Either they've been doing edge computing in some way, shape, or form for a long time, or they're doing it for the first time now. Organizations, they probably have a good understanding of what modernization means to them. Retail is a good example. Again, they've been implementing infrastructure for a long time, but typically they want to go down a path of modernizing that infrastructure. What that means is bringing more IT concepts into maybe a world that has been dominated historically by OT or operational technology kind of concepts. They want to move into a world where they're taking the same principles for how they build and manage infrastructure and applications in the data center and maybe in the public cloud, and try and standardize on that approach all the way out to the edge. And so this is where you kind of get this maybe a bit more of a transformation in those organizations. And that's where we come in as a software vendor who is very active in the edge space, helping them to go through that modernization. Many of these organizations, they don't really know where to start. They know that they need to try and modernize their infrastructure because it gives them a unique business advantage, but they don't necessarily know where to start.
Do you see any Nordic differences?
I would say not a lot. I mean, we say we are very digitalized in the Nordics, and I speak to different organizations. We call it traditional manufacturers. It could be one good example, without jumping in and pointing at any specific organization, is within the mining industry, where you've gone from delivering hardware in terms of a truck or something like that to be used in a mine. And you deliver the truck, in best case, you service the truck at some point in time. But companies are moving to more of an autonomous space. They want to reduce the footprint of us as a human within the mine, because that reduces the risk of actually running the mine. That means that everything within the truck will be operated from afar. So the drivers will sit somewhere else. They even move towards autonomous mining, which puts a whole new perspective on how they need to run IT and IT infrastructure. And there's not necessarily a connection right now to the edge area, because we use different wording for it. But it is a very good example of edge cases that are developed and quite far ahead within the Nordics.
Do we have the connectivity that edge requires?
And that's just the thing. We cannot rely on the connectivity, right? So when you're in a mine, I know that there are specific companies working with connectivity within confined spaces, and mine is a very confined space, of course. But we cannot rely on that connectivity. So we need to have edge compute power that can basically make their own decisions as it runs. Decide where they need to scoop up rock that has been blown away from a rock face, where to bring those rocks and how to handle it, how to go about bringing them there. So the connectivity part is really essential, I would say, or the lack of connectivity for edge computing.
Connectivity is not always guaranteed, right?
Exactly.
And even when connectivity is available, it may be slow, expensive, or coming in and out. An example, we've worked with a number of customers in the marine industry, and they're doing kind of modernization of their infrastructure within the ship. And it could be because they want to run applications on the ship, maybe for not passengers, but the workers on the ship, providing them with additional services, or it is managing systems within the ship itself. So, things like utilizing various different data sources, such as sensors, to ensure that the ship is performing as expected. In those situations, there's no guarantee of connectivity between the container ship or the vessel and the back-end infrastructure. So if you are the IT organization behind that company, you don't necessarily know what is happening within the ship and within that infrastructure. Are the applications behaving as expected? Is the infrastructure working? Or more importantly, is the vessel performing as it should? And so in that scenario, the connectivity between the back-end infrastructure and the ship is typically over a satellite link. Satellites are notorious for being, in many cases they're quite fast, but the latency is very, very high. And there are areas where you won't have the coverage that you need. And so these systems, they need to be as self-sufficient as possible. And self-sufficiency in that they don't rely on connectivity to the back-end infrastructure. They are as resilient as possible, and that they require very little user intervention. Because that's the other thing with edge computing. If you look at that vessel, or indeed a fast food restaurant, you cannot expect the employees that are working very close to that infrastructure to understand how the software works. You know, from us, we utilize components such as Linux and Kubernetes. With the greatest of respect to them, the fast food restaurant employees, it's unlikely that they're going to have the skills to be able to debug and troubleshoot software. They expect it just to work. And we even heard one example from one of our fast food customers that said, we've had it in the past where there was a device that was doing, you know, order processing and payment processing, and the device gets unplugged because one of the employees plugs their mobile phone in to be charged. I mean, it's kind of a funny example, but it shows that this system needs to be as resilient as possible. It's going to be somewhat abused. It needs to be turned off and on and off, and just expected to work. And so these systems need to be as resilient as possible.
But it sounds, if I'm listening to what you're saying with some kind of geopolitical ear, I could hear that you're saying that it could actually be a competitive leverage to be able to run your operations without trusting the infrastructure, because we can't always rely on it. It would also be some kind of a society resilience leverage to be able to run the society without the internet or infrastructure. Is that one interpretation of the benefits of Edge?
I agree with you very much. But let me take it a slightly different direction and make it a little bit more broader around security and compliance and governance, or risk, I should really say. When you're putting IT infrastructure much closer to the user, again, we go back to the fast food example, or to make it even more challenging, a medical setting, because what could be more important than medical data? When you put that infrastructure much closer to a user or the public, you are exposing yourself to many more risks. The threat vectors or the attack vectors are much broader than they would have been in a more traditional setting. In a traditional setting, the way that you attack the system is through the network. When you are in a fast food restaurant, the system is there. And because these are off-the-shelf hardware, you have standard ports, you have a network port, you have a USB port. These are attack vectors that you wouldn't usually have. And so what that means is that the software and the whole stack essentially needs to be as secure and tamper-proof as possible. Because if you are an organization that's putting infrastructure into a hospital, and again, that medical data is really important, if you have a breach of that, you lose the trust and confidence of not only the patients, but also, you know, the nation. And so what we do at SUSE is we take a multi kind of stage approach to security. We have a more of a secure by default methodology. So that is making sure that anything that we do from a software perspective is set out to be enabled in the most restrictive of settings. So we kind of call it a bit more of a zero trust. We trust nothing. We assume that everything is always being compromised. But also, if you look at what is happening in the world with regards to new legislation and regulations that are coming in, you look at DIS2 and various DORA, and things like that, we end up in a situation where organizations are forced to prove that they are doing everything they possibly can to protect data, infrastructure, and applications. And so we, as a software vendor, we have to be able to prove to our end customers that we are able to meet all of these requirements. And so yeah, going back to your original question, yeah, I do think that there is a lot at play here, especially with geopolitics and how we protect critical infrastructure.
Mm-hmm. Can I ask one more?
Go ahead.
Because we're following supply chain attacks quite intense right now. Mm-hmm. And supply chain attacks takes very, very different forms.
Sure.
What about software supply chain?
Yeah.
Hugely important, of course.
Hugely important.
Something we work very intensely with. And,
yeah.
Yep. You want to
Yeah, sure. Sorry,
dig down
don't mean to monopolize it. Yeah. No, this is very important to us. It's also very important to our customers. They need to, and especially when regulations, new legislation is coming out across Europe and broader, organizations need to know where the software has come from, who has approved certain things going in, and generally we say that. Open source software is a really good way of validating what has gone in. You know, anyone can go and view the code that went in. But as a software vendor, we have to make sure that we are able to demonstrate a secure software supply chain, where everything was built, how it was built, who approved changes to the code. You know, it's one thing to see all of the code, but also proving who did that. And we need to be able to demonstrate to our customers and to legislators, essentially, that we are doing everything we can to prove it. There are a few, or more recently, there was an exploit that happened that you may have heard of. It's an XZ library exploit, and that took many months, potentially even years, for the malicious actor to get code into a part of the software that almost every vendor is using. And this was more of I guess, a breach of trust. But the software supply chain, the secure software supply chain, helps prevent these. Because, for example, you need multiple people to say, okay, I approve this change. And you're able to see the whole chain of events that led up to you as an end customer receiving and utilizing that software.
And I think the benefits for end users, if you're looking at vendors to work with in the edge space, you need to look at software's secure supply chain as one part.
Yes.
Since we briefly touched on it, it's a very different security setting when you move out from a traditional data center where you have walls that protect you, you have systems to let only certain personnel in and out. Now you find yourself in a space where you cannot control who's moving about there.
Yeah.
So it's something that we really encourage our customers to look at.
Yeah. And the one additional angle I'd bring to that, if you'll allow me, is scalability of edge. So if you've got 10 systems to look after and to secure, fairly trivial to be able to do it. If you've got 100 systems, it becomes a little bit more harder. You might need some automation to help you with that. But we have customers that are deploying tens of thousands of systems. You look at your retail stores, you mentioned a US example that we have that's, a number of thousands of stores. But if you are a fast food restaurant, a coffee store, or something like that, they have tens of thousands of locations. How do you manage deployment, updates, monitoring, the security across that infrastructure or across the fleet, especially as it crosses geographical borders and things like that? So these are some of the challenges that we have to try and think about in a world that we have to assume is always hostile. That is, we should assume it's always compromised. And so this is the level of trust and confidence that we have to build into our software and demonstrate to our customers that we know how to do this.
Yep. I thought about this international look, because when we asked Swedish organizations how they're planning to invest in edge computing, it was like 6.8% or something like that, saying that, and that doesn't sound that much. Why is it so slow, and how does it look in other countries?
Yeah. So I think first of all, I think that's an interesting.
It might be, as you said, maybe they're using edge computing, but they don't know it. But
I think that probably has something to do with it.
Yeah.
I mean, from my perspective, I think many different organizations, use cases, market segments, types of customer, they all are probably doing something with edge computing, but they may not necessarily associate that to edge computing as a terminology. Edge computing is, I guess, a little bit more of a buzzword. But
yeah, I think a good example, actually, when I came to think about it now, we talk about autonomous cars.
Yeah.
But that's an autonomous car is actually an edge device. Now, if you look at the car industry, the prediction is that about 30% of a car's actual value will come from the software in that car. And if you connect back again to what we spoke about earlier, which I think is a good example of edge computing. You really, when you're driving a car and you use the adaptive cruise control, for instance, you really don't want that adaptive cruise control to need to send data back to a data center to verify the distance to the car ahead. You want that compute power to take place in the car, so you know your car will actually brake if somebody brakes in front of you, right? So I think that's a very good example of an edge case that we don't call edge. It's an autonomous car.
Yep.
Yeah.
But it's a moving edge space, basically, right?
And if you talk to edge computing to the customers, who do you talk to? Is it the CIOs, CTOs, R&D departments, or?
That's a good question as well.
Yeah, it is a very good
with
question.
a broad answer, I think.
Unfortunately, it's a bit of a cop-out answer, and I just have to say it's the whole range of individual. I think it often depends on the maturity of the organization in terms of them embracing edge computing. You know, maybe they're already well into the weeds. They kind of know the direction that they want to go down, and in those situations, we would typically talk to either product owners or the engineers or the architects that are actually implementing it. And then in many cases, it's for those organizations that are just getting into it and trying to better understand how edge computing can give them a business advantage. It might be maybe some of the higher levels, maybe more of the IT owners or the CIOs, those sorts of individuals. It's very broad, and actually I think from my perspective in my role, it's really exciting to be able to talk at all levels.
Yeah. And I would say that one type of individual that we've started to engage more and more with is the cybersecurity officers. So the CISOs are coming more and more into the picture, because it could be, for instance, I know of companies that have expressly say that cybersecurity is one of our unique selling points. We're going to bring that with us in our in the cases that they bring to their customers. And again, the CISOs have kind of woken up to a reality where we leave the data center. First, we left it for the cloud. That brought on new challenges, but the cloud is just a data center, right? Now we're leaving the confined space again, the security that we have felt for such a long time, and now we're finding ourselves out in the streets. And how do we make that secure and a part of the offering that our customers make to their customers?
And it sounds like they increase the risk. So how do you talk about that with the customers?
Well, first, you have to make our customers aware of the risk to make sure that they see it, and then you need to connect it to their business opportunities and the business challenges. And from there on, we don't, as usual, we don't take, we cannot secure our customers by ourselves. We need to work very closely with our customer CISOs to make sure that they identify the risks and potential risks further ahead, of course, as well. And then from our perspective, again, the software secure supply chain is critical in what we can bring as an organization to them.
Do we have any questions from the crowd?
Yes, we have.
Oh, nice.
Do you want us to go there?
Yeah, I think we're good.
Yeah, good. We have a couple of questions here to address. Starting off with a retail example, I think. How do the retailers then leverage on insights from the complete corporation if a lot of the data handling is distributed in edge networks?
Yeah, very interesting. So I think that the collection of data is actually happening at the retail store. And many decisions can be enacted on there and then within the retail location. This is one of the advantages of doing so. It could be payment processing systems. It could be, as I mentioned, theft detection, customer tracking for reorganizing the store if required. But that doesn't mean that the data is isolated to that retail location. That data can be made available for remote processing, remote archiving, or aggregation of data to make better use of aggregated data for trend analysis. Just because you are receiving one result or one outcome from data processed in a single store doesn't mean that that is the model that would apply to all of them. We get better outcomes or more accurate outcomes when we're able to aggregate data from multiple different stores. And so, yeah, certainly customers have to be able to leverage that data and collect it together, and that's what centralized processing is needed for.
Yeah. Good answer, I think. Next one is from a probably frustrated CIO, I think.
Okay.
We have IT operations,
Yeah.
we have IoT operations, we have OT operations, and now we are talking about edge operations. Or is edge part of the three other platform areas that needs to be consolidated at?
Yeah. I think that edge is more of a superset of some of these terms. Let me try and unpack that. So what we're seeing is that organizations are looking to move more IT concepts, applications and infrastructure out to the edge of their network. And as we know, that can be a wide variety of settings, could be a manufacturing, shop floor, retail setting. And in that world, historically, they've been dominated by OT or operational technology concepts, which don't necessarily overlap with IT. You know, IT is more about deployment of infrastructure and applications and life cycling of them. OT is more about what is actually happening in that setting. It's the interfacing with machinery. It's a collection of data and doing processing, and the process behind it. Absolutely, it is. And so you have these different practitioners that really that have maybe a historical approach and an idea about how some of these things work, and there's this friction point between them. Because OT practitioners are being forced to learn more about how IT is kind of taking over with regards to standardization of software and infrastructure in those settings, but OT practitioners just want the system to behave as they expect it should, and to onboard some of the processes that they've been very much used to. And so there definitely is this kind of friction point between those two worlds, and I think edge computing is almost the battleground for where these things are going to be done. And then IoT is very interesting. So IoT, for those of you not familiar, it's the Internet of Things, and what we're really talking about here is where SUSE define it as more the tiny edge. And this is all of the hundreds of thousands of different data sources. And these data sources could be as simple as a webcam. It could be a temperature sensor, humidity sensor, or a detector on a simple example. We have a customer that does bottling of drinks. And very, very quickly, they're able to identify anomalies. And the anomalies will basically be discarded on the belt before it reaches the labeling. So basically, it helps maximize efficiency. So all of these sensors and these data capture devices, they need to be discovered. They need to be brought into the platform. The data needs to be captured, and applications need to be able to consume them. And so there are lots of worlds that are collapsing into one, and trying to provide standardization around the processes behind them, from the IT world, the OT world, IoT, where these devices come from, how do we secure them, how do we get applications to use them. It is this really, this world that is really converging together. We very much feel that we are at the forefront of that with many of our partners in the industry, but it is a world that is still emerging, and so I understand some of the frustration that they're going through.
I think we have two questions here that needs to be addressed. One is around AI, which is often discussed, and the last one will be around sustainability.
Okay.
And I think the question is deciding which data should be sent to the data center for deeper analysis can be difficult.
Yeah.
What's your take on send all versus, send all the data, send all the empower data, because data is now used at the edge of your processes.
Yeah.
Or to use AI to decide what data to be.
Yeah. Another very interesting question. I think AI is probably one of the most fascinating areas of technology that we're working through now. Many of our customers are looking to leverage AI capabilities to do analysis of data and to make some of those decisions where they're able to immediately take decisions rather than wait for either a human or back-end processing to make that decision. I think there's not really a one-size-fits-all answer here. Many of the customers that we work with will absolutely look to leverage AI to identify what is the important data. Can we use AI to process that data there and then, or do we ship all of the data?
Work with predictive maintenance and so on together in a joint setting with AI. So.
So I think the last question is a tricky one. In my opinion, edge computing can be both positive and negative for sustainability.
Okay.
We can reduce data center computing, but we also need to increase the usage outside of the data center, the compute, and also increase data transfers. Are we increasing or decreasing our carbon footprint by using edge?
Super tough question. I think we can go back to our maritime example that
I want
we
a yes or a no.
Yes. I don't know what I'm asking. No, the maritime example that we have, actually, a customer using edge technology to reduce the carbon footprint and in terms of a better operation of shipping routes and the actual vessel. So they already have compute power on the vessel, right? But they didn't have, or now they have a good opportunity to manage that compute power and to make sure that it's resilient and it always works. That compute power on the ship helps them to optimize route planning, help them to optimize the utilization of the engine and so on the ship itself. And if you compare the exhausts from a huge ship, it's far beyond the exhaust that I think, and now I'm a layman in sustainability, but of the edge technology that is involved in this. Yeah. So I think the appliance of edge technology in certain use cases is the thing that works in close cooperation with sustainability goals. And so.
Yeah. But I guess we can agree on that the compute power needs to be increased. But I think we're working very much with energy efficiency. And on the other hand, we have gains by using this technology that could actually be positive when it comes to sustainability.
Absolutely. Yeah. And just to maybe give a little bit more of a technical spin on this, compute capacity or capability is always increasing, especially if you look at more some of the work we're doing around GPUs and AI and things like that. But at the same time, the efficiency of the hardware is also getting better and better and better all the time. And so, you look at the latest developments from all the different architectures that we're working through, we're moving to a much more energy efficient hardware platform. Yeah. So I don't have data off the top of my head, but I would bet that we are actually moving to a world where, yes, capacity is going up and capability is going up, but from a ratio of energy consumption, we're probably staying around about the same level.
Yeah. Okay. So one more question.
Oh,
one more. I think that
I have lost later.
Because I think this is a smart one. What types of workloads or use cases should we look at first? What are the low-hanging fruits?
So types of applications. I think it very much depends on the setting, right? The various different use cases.
Yeah, I would say. The boring general answer is that there's no single solution that applies to everybody.
No, but I guess
so we need to
where data makes a difference and where latency latency difference, maybe.
So can we use the example of one of our customers here in the Nordics, actually, that is a manufacturing company that has said that in order to process their orders, they in their factories, they need to be able to run the factory 3 days without any connection to the outside world. They cannot do that without edge computing. They need the compute power close to the robots, close to the production lines. So that's a brilliant use case for edge computing, and immediately connected to the value, because they can see the output during 3 days, what happens if we can't do it, and you can basically draw a straight line to the revenue that they would lose if they couldn't produce and send out the orders.
Yeah.
So I think it's as usual, don't use technology for technology, tie it into a proper use case.
Mm-hmm.
Yeah.
Good.
And if we should finish it off, you have 3 takeaways for the audience to...
3 takeaways, goodness. So the first one I'd probably say is when you look at moving infrastructure and applications much closer to the, as we said, the user, the source of data or the subscriber, you are naturally going to be involved in an area that is perhaps more constrained, or it has additional security challenges that you need to be aware of. Consider that what you used to rely on in the data center in terms of security, automation, guarantees of connectivity, latency, and bandwidth are not going to be there at the edge, or not in all circumstances. Think about some of those constraints, how you work around them, and how you implement a resilient and reliable infrastructure for your use case in that environment. That would be my first one. Do you have a second one?
I would say the second one is that if you don't do it already, look into what the open source industry can actually offer. It is open source. Not only we, but many suppliers within the open source area you can just bring the value to you without and having a look, experimenting, use the innovation of the open source industry to help you move faster into this space.
Yeah. It also gives you the ability to leverage new technologies as soon as they become available.
Yeah.
So you have a lot of flexibility, freedom of lock-in and things like that. The third one would be around, we've already talked about it briefly, but regulations, legislation that is coming in. In many ways, this, of course, is very, very good for the industry. It's very good from a data protection, a security and compliance perspective, but also it is going to force you as organizations to take a lot of responsibility for the way in which you are deploying your infrastructure, your applications, protecting data. Working with vendors such as ourselves, we, of course, have to take this very, very seriously, and we absolutely do. But the responsibility is still on your shoulders to adhere to it. So there's a lot more legislation coming. A lot of legislation is being discussed right now. And so staying on top of that is going to be critically important, especially when you are working in, shall we say, more hostile environments.
Thanks. Good. And thank you very much for today.
Ja, tusen tack.
Yeah.
Thank you.
Tack.
Thanks.
Tack.